All right, everyone. Hugo Bound Anderson here from Outerbounds. We're here for our Outerbounds webinar, which I'm very excited to be speaking with Will High from Tala today. Hey, Will.
Hi.
How are things?
Things are great. Nice speaking with you.
Likewise, and as you know, but letting the viewers know, I'm here in Sydney, Australia, and you're there in lush, verdant, beautiful, rainforesty Portland, Oregon.
Yeah, you caught us in our 5 minutes of sunlight today. Amazing look.
Exactly, and we're getting close to summer here now, so the sun's coming up earlier and earlier. So we're here to talk about all the great things you do at Tala, and how you use data science and machine learning and leverage AI, and how you use Metaflow and Out of Bounds as well. For those viewers who don't know, Metaflow is a framework and productivity tool for data scientists and machine learning engineers that allow them to focus on all the stuff they love at the top of the stack, such as modeling and deploying models, while having access to all the infrastructure below. And we'll include some links if you want to check out what Metaflow does. And we do this at Out of Bounds, where we provide products based around it as well. We'll be talking about the Out of Bounds platform with Will today. A bit of background for Will. Will, you are at Tala, of course, but before this, you're at Discord. Before that, you're at Netflix, which, of course, is where Metaflow has its origin story. Built there in 2017, open sourced in 2019, right?
Yeah, I was there in the very beginning. I was one of the early users of a serving platform, actually, that the Metaflow developers were building, as well as the batch processing platform that we all know and love, and ended up being the core product. Yeah, I was a very early pioneer user of it, I would call myself. So I've seen a lot of iterations of it over time. And, I was there when it was open sourced, and when Ville and team spun out their company, Outerbounds, from that. And yeah, working with Ville and team at that time was it was a very important experience for me, because I learned that there are developers out there who care very intensely about the developer experience, especially of the data scientists. That was a new concept to me at the time, to have someone so passionate about it, and it really came through in the products he was building. So it was a joy to work with him at that time, and it's still a joy to work with the Metaflow platform.
Amazing. That's wonderful to hear, and that's part of why I joined Out of Bounds and Metaflow as well. You may recall that my background is in research science, so I worked with some of the best scientists I've ever met, who didn't have access to the tools and education they needed to do the science that they were very capable of doing in every other respect, because a lot of people who build software tools and frameworks, I think, assume that scientists are or have the skills of classic software engineers, which, of course, not only don't they, but perhaps they shouldn't, in order to build the data science, machine learning, and AI software that they need to today.
Oh, I completely agree with that. And I've thought so much about that question over the years. Data scientists, are often deep in some technical field, and they should stay deep in that technical field if that's their primary interest. So, if they're deep on some specific kind of modeling or statistics or whatever, they shouldn't have to be deep on engineering if they don't want to, and it doesn't serve their interests or the interests of those who they work for. And so but it was also evident, and I remember this at Netflix, it was also evident that we data scientists needed the benefit of scale, especially horizontal scale. And Ville, I remember very distinctly, had a very strong vision of, he used to say some version of what they really need is horizontal scale, not vertical scale. We don't need fancy multi-threading and message passing and whatever. We just need more computers, usually at a time, to optimize a hyperparameter grid, or to just run bigger models or more steps or big steps optionally, with giant RAM or GPU here and there. It became very clear that Docker and sort of containerized horizontal scale, like that was going to do it, but it was still kind of too hard to operate that. And that's where Relay was like, no, what we need is just the simplest, horizontally scalable, containerized system that is extremely user-friendly and Python-based, that gets you out of YAML specifically or some other DSL. That vision is like persists today, and you can still see it. And so what it means is like scientists like you and me can write Python all day instead of YAML, instead of YAML and JSON, and still get the benefits of scale and a bunch of other features from Metaflow. So I
absolutely. Yeah. And as we were discussing previously, it is in the long lineage of not a lot, but some Python packages and frameworks which have prioritized developer experience, such as Spacey and scikit-learn and Keras. And I'm very proud that Metaflow exists in the same space of trying to make data scientists and machine learning engineers' jobs as easy as possible. Speaking of which, you are the head of machine learning data science at Tala. So I thought maybe we could start by you telling us a bit about what Tala does.
Yeah, sure. I lead the machine learning engineering platform team and the data scientists, including machine learning and causal inference and experimentation data scientists at Tala. Tala is a fintech startup, fairly later stage startup, pretty successful later stage. We are a financial platform for the global majority of people who lack access to traditional financial services. So these are a lot of people, and we're talking about 4 billion people, most of whom do not have traditional relationships with banks or credit scores. And we are oftentimes the first credit entity to create a credit score for these people, which is an amazing privilege for us to be able to do, to get them into the ecosystem and smooth out some of their financial shocks. So our credit scores are driven by some innovative uses of machine learning. We have to do that because we can't leverage other institutions' credit scores to be able to do that. It drives some other core parts of our business, including fraud detection and our recoveries operations. And we operate in 3 countries right now: Mexico, Philippines, and Kenya. And we have aspirations to operate and serve even more people in the future.
I also understand that a core part of your mission and identity is humane collection practices also.
Yeah, I'm particularly proud about that. We're a lender. We offer uncollateralized credit products, and so we fund the business. And we're also for profit with a human mission. So we do try to have a self-sustaining business through interest rates. It does mean that at times people can't pay back or are late or can only pay back a fraction. So yeah, I'm particularly proud that our collections practices are very humane. We're pretty gentle, forgiving, and respectful when payments go delinquent. Our priority truly is to have long-term customers. So if people reach a snag, we're very gentle about it. We do reach out to them and try to work out something where, maybe it's partial, maybe it's later, and that's fine, because our priority is re-engaging them over their lifetime. So it's pretty great that we're able to do that. And that comes across quite a bit in our own customer testimonials. It's very heartening to see people's reactions to the way that we do collections as compared to some competitors. So I'm particularly happy about that part of our mission.
Wonderful. So what I'm really interested in is what makes data science and machine learning at Tala specifically important? Why does Tala have a significant data science and ML function?
Yeah, machine learning models drive the core of our business. It's what underlies our credit scoring and our underwriting capability. We do have a real-time credit score serving infrastructure, so people get decisions essentially in real time when they apply for a loan or reapply when they're made another offer. And it's at the heart, truly at the heart of our business operations and our ability to generate revenue and profit. It's very exciting to be right in the middle of the business in that way, and it's a high bar, and machine learning is absolutely critical to what Tala does.
Fantastic. So I'm really interested in what Outerbounds features you find most useful and why.
Yeah, so we're a subscriber to the Outerbounds platform services. When we spun up Metaflow initially, we wanted to do it ourselves, so we took the open source version and we figured it out. And then we realized somewhere in that process that we would also benefit from some of the Outerbounds functionality. Some of my favorite functionality includes, I guess the obvious thing is support. So the ability to like reach out to core developers of Metaflow and get responses on a very good SLA for us is absolutely, it's a game changer for us. Super responsive, honestly. And it's with people, again, that I've known forever. And so I like know where they're coming from as people. They're genuinely interested and enthusiastic about helping us. And they've made it very clear, like, there are no stupid questions. And this is one of the barriers of data scientists in contributing core code to any operation, any company, is it's sort of like you feel kind of dumb because you don't know as much as the developers who are next to you. And Ville and Savin and Oleg and others are it's very clear that they enjoy helping data scientists and engineers, and no questions are off the table. It's a huge benefit, and it's a huge weight off our shoulders, all of our shoulders, to be able to ask what end up sometimes being simple Python questions. The other part that we really like is the dashboard. The Metaflow job dashboard that is served through the Outerbounds portal is really beautiful. It's read-only at this time. I think there are plans to develop further functionality in it that are actively being developed right now. But we use that regularly. We use Metaflow on Kubernetes using also Argo workflows. That's how we that's our stack, our Metaflow stack. And we do use the Argo workflow UI. It's okay. It's not as slick as the Outerbounds job UI. So we do use the Argo workflow UI when needed. There's a couple pieces of functionality that we need out of there, but for the most part, we're in the Outerbounds one. It's just a better experience, and it's very, very clean. And the other thing we use a lot is the workstations. So when I was at Discord, they were using code spaces, I think it was called, to do development in our favorite IDE. For most of us, is VS Code or PyCharm, in the cloud against sort of scalable compute resources. So code spaces enables that. And Outerbounds pitched workstations to us, and it reminded me quite a bit of that. So we tried it earlier this year, and it's an awesome way to like use the existing Kubernetes cluster resources that we have already provisioned in an on-demand way still, but to be able to log into them directly and get all of sort of the Metaflow credentials natively without any additional work, and to develop in a VS Code IDE, which is really clean. It kind of shortens that development loop by a lot, and it sidesteps a lot of credential wrangling that we'd otherwise have to do with ourselves and with DevOps and to try to figure out in the AWS console. It just makes all that happen naturally, and it's very easy to use. It's well designed, in my opinion. And so we scaled this out to all of our data scientists and our machine learning engineers, and actually to analysts across functions in other departments. So our credit finance analysts who already know Python and like were hired in part for their Python capabilities. They run notebooks as part of their day-to-day, and they're using Metaflow Outerbounds workstations also to run Jupyter Notebook servers in our clusters. And again, they get to download data natively, like on region, from S3 or wherever we're sharing data. They don't have to do a big download across the network. It happens very quickly in the same region, and it's all the same Jupyter Notebook experience that they're already used to. So yeah, we've scaled it out to even beyond our team.
That's very cool. And actually, in the spirit of an image being worth at least 1,000 words, I just want to share my screen briefly. Can you see my screen, Will?
I can, yes.
So these are the types of things you're talking about, right? This kind of illustrates how our workstations work, that you can, explore with notebooks, create a workflow. You can also track everything, visualize results, and then you can scale up and out. And this is what you're saying you use Argo for, essentially, scheduling and making reactive systems as well. And then the ability to iterate quickly and debug and improve, moving from up here back to some form of local workstation.
Yeah, and I have to say, this is a concept I'm like obsessed with, which is shortening the development loop and using the same like machines that are used in productions. The more you like get away from that and have to spin up Docker in another environment or on another compute, even in another region, the farther you get away from your production environment, the longer the development loop. And the workstations are directly on the same cluster that we train our models in production using the scheduled execution box that you mentioned there with Argo workflows. So we're like 100% confident it's the same cluster, same credentials, same Docker images. We can pull our own custom Docker images that we've already baked from in ECR in our jobs directly, as well as in our workflow, in our workstation. So we've like normalized environment. That's how we solve Python package versions and also the lower level OS versioning. And yeah, it really does. It makes this entire loop. All of it happens on the same infrastructure, and it's very, very quick for us. It's a really good experience.
That's fantastic. And that really dovetails neatly into what I wanted to talk about next is, how do you think about making data scientists more productive, and how does Outerbounds help here? And you even mentioned you've got financial analysts working with these tools.
Yeah, I do hire for, and I encourage data scientists to be interested in the day-to-day concerns of a very strong software developer and architect. At least admiring what a very good developer does is sort of like our barrier to entry. Even if we ourselves never in our lifetimes like become that good, at least we admire it and we respect it, right? But I don't want to go so far as to ask every data scientist to become like as strong as any staff or principal software developer. I want them to continue to go deeper and deeper into the analytical area of specialty that interests them the most. So that's always going to be my priority. And then what I really want is people who kind of want to do both to some degree. So that's kind of how I think of it. And so we've pulled all of our jobs at Tala. All of our core models are now built and trained on Metaflow, which is great because now we get to just like hit a button. And it did take us took us about a quarter and a half to get our core models implemented and fully validated. But now that it's done, it's push buttons for us, and we can even schedule the refresh of these models, and then any updates are like very quick. So what happens is, for us, we experienced a huge jump in free time. Free time's not quite doing it justice. In less time spent sort of wrangling infrastructure and compute in AWS. And a lot of that time is going into more research, more of the like stuff that our data scientists really want to be thinking about most of the time. We shifted from what was maybe about 20-30% research time while we were doing this big migration onto Metaflow to 50% and above of research time. And yeah, and we can still sleep at night knowing that we can retrain models, or they're being automatically refreshed on a weekly or monthly basis against the latest Python packages or whatever is happening with the requirements, knowing that we'd be able to deploy those changes and still be able to continue to do spend most of our time doing research. So that's the big shift. It's really fun to be at this stage and for the data scientists to get back into research.
I'm also interested in terms of how much it has improved, I suppose, the iterative loop and how long it takes to like retrain an existing production model and getting it back into production and that type of stuff.
Yeah, so we did what Tala did, what every AWS based startup would do. They leaned into EC2 instances, and each data scientist would get their own EC2, and they saw it as their machine, and they would build models on it, spin up their own notebook servers. They would oftentimes, early enough in Tala's lifetime, they would create their own permissions to access databases to deploy to production. So they'd have to get really good at the AWS console. That shifted to a first-class function with our DevOps teams now. So that turned into making requests to DevOps and waiting for those requests to be fulfilled and validated, right? So all of this ended up taking quite a bit of time as time went on. The spinning up of new EC2 machines would take some time. Requests for permissions, specific permissions to the task at hand, that would take some time. We also have acceptance testing using an SDET function. So we have to make requests to those teams. Every time we have to like throw over the fence, we'd have to wait to get on other teams' sprints, and we'd cross our fingers that they would have budgeted for these sort of ad hoc requests. But it became clear that it wasn't truly workable. It would take months, honestly. It would take many months to build a brand new model from scratch, right? And then even refreshing an existing model or getting like a new data scientist spun up on an existing core model, it would take longer than we wanted, right? So because of that migration that we did onto Metaflow, as well as some optimizations that we did on our end of getting the models from the Metaflow store into serving, we happen to use SageMaker, and then we have a custom feature extraction service that we run on another Kubernetes cluster. So we made a lot of improvements with Year, and just last week, actually, I formally announced to the company that we reached the end of the first stage of that, which is the MVP of all of those components that I've just mentioned. Mm-hmm. And I ran the numbers, and we got something like 1,000x speed up just in the time it takes to start a model training run for, let's say, a brand new data scientist joining the team. It went from many weeks or months to I did a demo for the company about a month ago. to less than 10 minutes once you're on a workstation. From a workstation, triggering a run, it took less than 10 minutes. So it's just like a massive speed up and productivity gain from all of that work. And the other beauty part of it, which is I feel underappreciated, is we now, because we're using Metaflow, we now have a full record of all historical research and training runs that have ever been done using the Metaflow infrastructure. So, you know, we set these jobs running, and we take it for granted right now that all the data is persisted into the cloud in S3 in our case. But if and when we discover issues 3 months, 6 months from now that we want to like look back on, we can do a 6 month or 1 year retrospective against the actual data artifacts we used and the code that was used at that time. And we got all of that for free. We were going to try to build that ourselves when we were evaluating Metaflow about a year ago. And we ended up deciding to go with Metaflow, and we got all of these like features, including a model registry, a data artifact store, and a bunch of other things for free. And I think we're gonna reap the benefits of that for a very, very long time. So yeah, huge speed ups and have happened because of our Metaflow and other migrations this year.
That's so wonderful to hear. And I, in all honesty, would love, 1000x speed ups in a lot of things in my work and life currently to get everything done. So this is all wonderful to hear. Of course, not everything is ever. So I am wondering what some of the remaining challenges are.
Yeah, we still have more models to get onto Metaflow. We run a feature store. We have a feature store solution that we've rolled ourselves. And we have a lot of work there to get everything onto the new feature store, get everything acceptance tested in there, and then get the rest of our model types sort of implemented in Metaflow. So that's still an ongoing process. Our core underwriting has been ported, but some of the other ones haven't quite yet. So we're doing that. We're also in a profit generating phase. We're optimizing to revenue and profit instead of growth, like probably every other company in this economic climate right now. So we've been able to pivot into that successfully, thankfully, but part of that has been optimizing our compute costs and our fixed costs related to HQ operations. So it's a pretty high bar on our profit generation. Metaflow turns out to be a core part of that because all of the compute is on demand and ephemeral and containerized. So resources are shared, RAM and CPU are shared. Because of all that, and especially because we moved away from EC2, which is always on unless you manually turn it off and then manually turn it back on. We get a big cost efficiency gain, but we're still having to continue to optimize some of our jobs so that they don't blow up in terms of number of nodes. So we're doing some optimizations around our existing model implementations in Metaflow. And another interesting challenge at Tala is we operate in very different markets across the world, and there's different regulatory requirements. One of them at times is the data needs to stay on local soil. So we try to operate in local AWS regions, and I know that's very common, keeping AWS instances close to the customers. So we try to do that as well, but we try to do that not just with our serving infrastructure, but with our models, our model trainers, and the raw data as well. So we've deployed Metaflow in local AWS regions, and we're trying to keep it there. So we're still trying to find ways to efficiently switch from region to region as we go. But right now, it's really easy to trigger jobs in for a Philippines market and for a Kenya market at the same time from our laptops in those local markets directly, in those local AWS regions directly. So we're doing that. Metaflow helped us quite a bit to make a lot of very substantial headway and actually get a little ahead of that compliance requirement that we have from some countries by default operating locally. So those are some of the challenges that we're faced with right now.
Cool. Well, those are super interesting. I'd be excited to check in again sometime soon to see how you're going with all of them.
Thank you very much. It's a pleasure to speak with you.
Always a pleasure. Thanks, Will.